Hello, good evening. This is Swapna, Mathematics faculty from EDUHUNT, IIT and NEET Academy. In the last session, we have discussed about the concept of sets and its cardinality of sets and equal sets and types of sets. We have discussed about types of sets, definition of set and all these things. And we also discussed about the worksheet 2 of our material. So in the session, I am going to discuss about worksheet number 2A. So let's begin the session. Okay. So here comes the first question. So what is the question here? If n of A means cardinality of A. This is representation of cardinality of set A, right? So cardinality of set A is equal to cardinality of set B. Then the two sets are equal to dash. I told you if two sets have equal number of elements, like if you have, for example, if set A is having 4 number of elements, set B is also having 4 number of elements, then we say those sets are equivalent sets. So option B will be your answer. So if the cardinality of two sets are equal, if the number of elements of two sets are equal, then we can say those both sets are equivalent sets. Can I get back to next question? Chalo. All equal sets are what sets? All equal sets are equivalent sets, right? Because for example, let us take an example of equal sets 1, 2, 3. This is set A and equal sets का definition ये होता है कि same number of elements should be there, right? 3, 2, 1. So this is an equal set. This is an example of where A comma B are equal sets, where A comma B are equal sets. So what they were asking you, all equal sets are null sets. Let us go with option verification. Equal sets, null sets are not, right? Because you are finding a common element and at the same time the intersection is not equal to empty. And proper subsets, no. And those are equivalent sets. Option D will be eliminated. It is none option. A is eliminated. Proper subsets. All equal sets are proper subsets. It may or may not, right? So equivalent sets are those sets, right? All equal sets are equivalent sets because n of A is equal to, what is the cardinality of the first set? 3. N of B is also equal to 3. So cardinality of first set is equal to cardinality of second set. That means those both are equivalent sets. Option B will be your correct. Okay. Next go to the question number 3. Okay, what is the question number 3? If C and D are equal sets, then and C contains first 5 multiples. So C is equal to D. What is a C set defines? C is equal to first 5 multiples of 5. First 5 multiples of 3, right? First 5 multiples of 3. So 3 1s are 3, 3 2s 6, 3 3s 9, 3 4s 12, 3 5s are 15. This is also equal to D because in the questions they gave you like C and D are same sets, equal sets. So equal sets means you will have a same elements, right? So option 3, 6, 9, 12, 15. Option C, if you can observe, it will be the answer. Whereas in the second one, it is like 6th multiple and this is the 7th multiple. But in the question they give you like it is the first 5 multiples of 3, right? Whereas this is 8th multiple, 6th multiple, 10th multiple. So this is not an option, this is not an option, even this is not an option. So option C will be the correct answer. I hope I am clear with this question. Can I get back to next one? Chalo, we'll get back to next question. So this is a sets. Here they have given in the sets, in the set A. In the set A, what are the elements you are having? 1, 3, 7, 5. In the set B, what you are having? In the set B, you are having like 5, 7, 3, 1. So in the set B you are having like 5, 7, 3, 1. So this is the option. Null and none options will become deleted because you are finding a common element, right? So null and common options will be deleted. So what will be the answer then? Tell me. So those both are equal sets because you are having same number of elements, 1, 3, 7, 5 and 1, 5, 3, 1. So 1 is there, 3 is there, 7 is there, 5 is there. Those are options of, this is an example of equal set, and equivalent set means you should have a cardinality is equal to 4, and this is also equivalent set. It is an example for both equal and equivalent sets. I hope I am clear with this. So n of A is equal to n of B is equal to 4. That means the number of elements are equal to same, and at the same time you are having equal sets, equivalent sets. Can I get back to next question? Yeah. So what is my next question? If n of A is equal to 6, means cardinality of set A is equal to 6 and A contain integers, okay, those contain integers between -3 and 4, between -3 and 4. So this is -3 and 4, right? What are the integers it locates? -2, 1, 0, 1, 2, 3. So how many numbers are there? 1, 2, 3, 4, 5. So you have 5 elements. So it should contain like 1, 2, 3, 4, 5, 6. So what is the set here they have mentioned? So set A is equal to cardinality of 6. Okay. Set A, how you will represent cardinality of 6? You will have a 6 elements, and those 6 elements are from -3 and 2 plus 4. So -2, -1, 0, 1, 2, 3. So what is the option then? Option C will be your answer. Am I clear? Can I get back to next question? So this is my next question. If the letters used in dear and read are represented in 2 sets respectively, then the 2 sets are dash sets. Obviously we have letters, right? We have letters, so we can able to, for example, let us represent the 2 given words in 2 different sets. The first set is DEAR and the second set is, let us take B is equal to READ, right? So then are represented with 2 sets respectively, then the 2 sets are dash sets. So if I take the infinite option, we can able to count the number of letters are there. So this is not an infinite option and this is not a null option too, because we have a common element from both the sets. And if you can observe, the letters are A, comma, D, comma, E, comma, R are same in both the letters, so it is actually equal sets, but here in the option it is given unequal. And yes, we can able to count the number of letters are there, so that means it is an finite. In the ichina sets lo any elements unnayo meer count cheyagalaru ante kadamma. So you can count number of elements are there. So n elements unnai 4 ante cardinality express chesinappudu that is a finite number of sets. I hope I am clear with this question. Next question. We'll begin the next question. So given C is a set where x minus 5 equal to 0, that means x is equal to 5, and represented D is another set, x square is equal to 25, then x is equal to plus or minus 5. X is equal to plus or minus 5. As usual, this is not infinite set, we can able to count, and this is not equal sets too, because here you are having 5, minus 5 is missing. Here you are having plus or minus 5, that is not an equal sets too. Whereas in finite sets, yes, it is a finite set, correct? That is not a null set because we have a common element 5. So yes, this is, we can able to count how many number of elements are there in the option C and D, sets C and D. So that means it is an example of finite sets. అంతేనా, ఎన్ని ఎలిమెంట్స్ ఉన్నాయో కౌంట్ చేసినప్పుడు అది మనకి ఫైనైట్ సెట్స్ అవుతాయి. కరెక్ట్. సో ఫర్ అటెంప్టింగ్ ఆల్ దిస్ టైప్ ఆఫ్ బిట్స్ యూ హ్యావ్ టు బి వెరీ మచ్ క్లియర్ అబౌట్ the definition and the theory examples. Okay, so let us go with the 8th question. The set of all proper fractions. Proper fraction, what is, how do you define a proper fraction? Tell me. Proper fraction means numerator must be less than denominator. This is the first condition, and each having 7 as a sum of numerator and denominator. Whenever you calculate the sum of numerator and denominator, it should come sum as 7 at the same time. That is my first condition. And second condition is you have to get a proper fraction. Okay, let us take all this. 1 plus 6 7, 2 plus 5 7, 3 plus 4 7. So if you add all the values, you are getting 7. Next, 1 plus 6 7, 4 plus 3 again 7, 5 plus 2, this is also equal to 7. Next one, 1 plus 6 7, 4 plus 3 7, 6 plus 1 7. Here also 2 plus 5 7, add 3 and 4, 3 plus 4 7, 4 plus 3 7. So if I'm adding all the numerators and denominators together, I'm getting 7 as a result. First condition is being satisfied by all the options, but it, along with this, it should also become a proper fraction. Proper fraction in the sense numerator is less than denominator. Let us check with this. 1 by 6, yes, numerator less than denominator. 2 by 5, proper fraction, proper fraction. So this may be the answer. Let us also check with the other options. 1 by 6, proper fraction, yes. 4 by 3, 4 by 3, whereas numerator is greater than denominator, that was an example of improper fraction. So that means option 2 and 4 by 3 is also exist here in the D bit. So that is the reason option A will be your answer. I am clear with this. Can I get back to next one? Yes. So what is my next question? If A is equal to set, what is that set? X is an integer and minus 2 less than x less than or equal to 3. Right? X integer avvali. Integer avuthu minus 2 less than x ante x greater than minus 2. So what are the options? Minus 1 maybe. Right? 0, 1, 2, up to 3 you have to take it, and you need to include 3, right? Because it is less than or equal to 3. So what are, how many number of elements are there? 1, 2, 3, 4, 5. If I ask cardinality of A, it is equal to 5, and of course in this question they did not ask. They asked you the elements. So option C will be your answer. Minus 1, 0, 1, 2, 3. Right? Which is greater than minus 1, greater than minus 2, and less than or equal to 3. We do exist this number of elements in the set. So we have n of A is equal to 5. Yes. So I hope I'm clear with this session, and I hope you have really enjoyed the session. Thank you all. Stay tuned. I'll be coming with the upcoming sessions. See you tomorrow. Bye bye.